Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method using another way of solving the problem. Part 2. Let's get going. Problem solve y double dash plus 3y dash plus 2y equal to sine e power x or d square plus 3d plus 2 into y equal to sine e power x using variation of parameters method. Given differential equation, y double dash plus 3y dash plus 2y equal to sine e power x. Consider it as equation number 1. We can write y double dash as d square y by dx square plus 3 into dy by dx plus 2y equal to sine e power x. Now we can write d square y by dx square as capital D square y plus 3 into write dy by dx as dy plus 2y equal to sine e power x. Now take y common from all the three terms of LHS. We'll get d square plus 3d plus 2 into y equal to sine e power x. Consider it as equation 2, which is in operator form. So f of d into y equal to some function of x, where f of d is d square plus 3d plus 2 and r of x is sine e power x. Let's now write the homogeneous equation to equation 2. The homogeneous equation to equation 2 is d square plus 3d plus 2 into y equal to 0. Consider it as equation 3. Now we'll find the solution to the homogeneous equation, and using the solution of homogeneous equation we'll find the general solution of equation 1 and equation 2. Okay, now let's see the auxiliary equation. Now coming to the auxiliary equation, the auxiliary equation is f of m equal to 0, where f of m equal to, just replace the differential operator d by m, so that we'll get f of m equal to m square plus 3m plus 2, right? Then the auxiliary equation becomes m square plus 3m plus 2 equal to 0. Now we need to find roots to this equation, so we'll split 3m as 2m or m plus 2m plus 2 equals to 0. From this we'll take m common from the first two terms, we'll get m times m plus 1, and take 2 common from the next two terms, we'll get 2 times m plus 1 equal to 0. Now take m plus 1 common, we'll get m plus 1 into m plus 2 equals to 0. Now equate each factor to 0. From m plus 1 equals to 0, we'll get m equal to minus 1. From m plus 2 equals to 0, we'll get m equal to minus 2. Then the roots are m equal to minus 1, minus 2, which are real and distinct. We know that when two roots say m1 and m2 are real and distinct, then the solution to homogeneous equation looks like one constant into e power one root into x plus another constant into e power another root into x. I'm taking C3, C4 instead of C1 and C2 because I want C1 and C2 to appear in the last general solution, right? Now coming to the solution to homogeneous equation. The solution to homogeneous equation 3 is y equal to c3 e power minus 1 into x plus c4 e power minus 2 into x. This gives us y equal to c3 e power minus x plus c4 e power minus 2x. Now using this solution, we'll find the general solution of equation 1 and equation 2. Let y equal to, now replace C3 and C4 constants or parameters with some functions of x, a and b. We'll get y equal to a e power minus x plus b e power minus 2x be the general solution of equation 1 and equation 2, where a and b are functions of x. Okay, now just compare y equal to c3 e power minus x plus c4 e power minus 2x with c3u plus c4v, or this y equal to e power minus x plus b e power minus 2x with au plus bv. From this you will get u equal to e power minus x, v equal to e power minus 2x. See, u equal to e power minus x and v equal to its v, e power minus 2x, right? Where u equal to e power minus x and b equal to e power minus 2x. Now we can find a dash and b dash using the formula. A dash is given by minus v into r of x by uv1 minus v1, and b dash is given by u into r of x by uv1 minus v1. Okay, if you notice, you're having uv1 minus v1 in both the formulas. So let's find, or let's begin with uv1 minus v1 now. Okay, we'll find uv1 minus v1, later we'll find a dash a, b dash b, and finally we'll come to the general solution y equal to a e power minus x plus b e power minus 2x. v1 is nothing but derivative of v with respect to x, minus v into u1 is nothing but derivative of u with respect to x. We have u and v, right? Where u is e power minus x into d by dx of v, e power minus 2x minus v into the derivative of u with respect to x. This gives us e power minus x into derivative of e power minus 2x with respect to x is minus 2 e power minus 2x minus e power minus 2x of derivative of e power minus x with respect to x is minus e power minus x. This is equals to minus 2 e power minus x, e power minus 2x, minus into minus plus, e power minus 2x into e power minus x, or e power minus x into e power minus 2x. See, we are having e power minus 2x into e power minus 2x in both the terms. Let's replace it. We can write e power minus 2x into, or e power minus x into e power minus 2x as e power minus x minus 2x, which gives us e power minus 3x. Let's replace e power minus x and e power minus 2x with e power minus 3x. We'll get minus 2 e power minus 3x plus e power minus 3x. Minus 2 e power minus 3x plus e power minus 3x is minus e power minus 3x. Therefore, uv1 minus v1 equal to minus e power minus 3x. A dash is given by minus v into r of x by uv1 minus v1, right? Then a dash equals to minus v e power minus 2x into r of x is sine e power x by uv1 minus v1 is minus e power minus 3x. This gives us e power minus 2x into sine e power x by e power minus 3x, or we can write it as e power 3x into e power minus 2x sine e power x, or we can split this fraction as, okay, reciprocal of e power minus 3x is e power 3x. Now we'll get e power 3x into e power minus 2x is e power minus 3x minus 2x, which is e power x. So just replace or write it as e power x into sine e power x. Therefore, a dash equals to e power x sine e power x. Let's now find a using a dash. We have a dash equals to e power x sine e power x, right? A dash is nothing but derivative of a with respect to x equals to e power x sine e power x. Let's now separate the variables by taking differential dx to RHS. Then we'll get, right? Here the variables are separable. We can perform integration. Integral dA equal to integral e power x sine e power x dx. So let e power x equals to t. Now differentiate on both sides with respect to x. Derivative of e power x with respect to x is e power x equals to dt by dx. From this we'll get e power x dx equals to dt, right? We can write the integrand as e sine e power x into e power x into dx. Now just replace e power x with t and e power x dx with dt. Then we'll get integral dA equal to integral sine t into dt. From this we'll get integral dA equal to integral sine t dt is minus cos t plus integral constant say c1. Since t equal to e power x, then we'll get a equal to minus cos e power x plus c1. Therefore a equal to minus cos e power x plus c1. Let's now find b dash and b. B dash is given by u into r of x by uv1 minus v1, where u is e power minus x into r of x is sine e power x by uv1 minus v1 is minus e power minus 3x. This is equals to minus e power minus x sine e power x by e power minus 3x, or we can write it as minus e power 3x into e power minus x into sine x, or instead of writing this directly, we can split this as minus e power minus x sine e power x into 1 by e power minus 3x. Reciprocal of e power minus 3x is e power 3x, right? From this we'll get minus reciprocal of e power minus 3x can be written as e power 3x into e power minus x sine e power x. This gives us minus e power 3x into e power minus x gives us e power 3x minus x, which is e power 2x, right? Let's replace it with e power 2x. Therefore, b dash equals to minus e power 2x sine e power x. Let's now find b using b dash. We have b dash equals to minus e power 2x sine e power x. B dash is nothing but derivative of b with respect to x equal to minus e power 2x sine e power x. Now let's separate the variables by taking differential dx to RHS, and we'll get db equal to e power minus e power 2x sine e power x dx. Here the variables are separable. So let's perform integration. Integral db equal to minus integral e power 2x sine e power x dx. Let e power x equals to some q. Now differentiate on both sides with respect to x. Derivative of e power x with respect to x is e power x equal to dq by dx. From this we'll get e power x dx equals to dq, right? Now we'll write e power 2x as e power x into e power x for our convenience, right? Again we can write this as e power x sine e power x into e power x dx, so that we can replace e power x dx with dq in the next step. Then we'll get integral db equal to minus integral, replace e power x with q, we'll get q sine q into e power x dx can be replaced with dq, right? Now let's find integral q sine q dq using integration by parts formula. We have integration by parts formula. Integral u dv equal to uv minus integral v du, right? Here the integrand is of the form product of polynomial function and trigonometric function, right? So let's consider the polynomial function as u and the remaining part as dv. Okay, u equal to q and dv equal to sine q dq. Now differentiate on both sides with respect to with respect to q. Then we'll get du by dq equal to derivative of q with respect to q is 1. From this we'll get du equal to dq. And here integrate on both sides to find v. We'll get v equal to integral sine q dq is minus cos q. Now apply this formula. Integral u q into dv sine q dq equal to u into v, u into v minus integral v into du. Du is equal to dq. This gives us minus q cos q, minus into minus plus integral cos q dq. This gives us minus q cos q plus integral cos q dq is sine q, right? Therefore integral q sine q dq equal to minus q cos q plus sine q, right? So from this we'll get integral db equal to minus integral q sine q is minus q cos q plus sine q plus integral constant say c2. Let's now replace q with e power x. From this we'll get b equal to q cos q minus sine q plus c2. Since q equal to e power x, this gives us b equal to e power x cos e power x minus sine e power x plus c2. Therefore b equal to e power x cos e power x minus sine e power x plus c2. We got b and a. Let's now write the general solution using y equal to a e power minus x plus b e power minus 2x. Therefore the general solution is given by y equal to a power minus x plus b power minus 2x. Substitute a and b. We have a minus cos e power x plus c1 into e power minus x plus b e power x cos e power x minus sine e power x plus c2 into e power minus 2x. This gives us minus e power minus x cos e power x plus c1 e power minus x plus e power minus 2x e power x cos x minus e power minus 2x sine e power x plus c2 e power minus 2x. Here we are having e power minus 2x into e power x, right? Can write this as e power minus 2x plus x, which gives us e power minus x. Now just replace this with e power minus x. We'll get e power minus x cos e power x plus c1 e power minus x plus e power minus x, it's cos e power x, okay? Cos e power x minus e power minus 2x sine e power x plus c2 e power minus 2x. This gives us here minus e power minus x cos e power x and plus e power minus x cos e power x gets cancelled and we'll get c1 e power minus x minus e power minus 2x sine e power x plus c2 e power minus 2x. This gives us, or we can write it as c1 e power minus x plus c2 e power minus 2x minus e power minus 2x sine e power x, which is the required solution. Therefore, y equal to c1 e power minus x plus c2 e power minus 2x minus e power minus 2x sine e power x is the required general solution to our problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you on the next video. Until then, bye bye.